A lot of this is going to be based on the work in Lewis Carroll in Numberland. We're going to be taking a look at how there's no such thing as a fair election. Now, there are opportunities to have a fair election, but they're very, very limited. A fair election can occur if 100% of the voters vote. And the other thing that would have to happen is that it would be two candidates and that the winner has 51% or more. Okay? So they'd have to have 51% or more of all of the votes in order for this to work. Let's look at the simple majority method. In this method, each elector names one candidate that they prefer, and he gets to vote. The greatest number of votes is taken as the winner. The extraordinary injustice of this method may be very easily shown, which they do in this book. They suppose that there's 11 voters and 4 candidates. The candidates are A, B, C, and D, and that each voter has arranged in a column the names of the candidates that they prefer. So the first voter preferred A, then C, then D, then B, and so on, all the way to the 11th voter. Here, A is considered to be the best by 3 of the voters, and the second best by all of the rest. And yet, by the above method, B would be the winner. A candidate who is considered the worst by 7 of the voters. So the winner gets the most votes, but would make the most people unhappy. And the non-winner would be the favorite second choice. So most should be able to, if they were thinking about the higher principle of not just I get what I want, but the best person for the job, the majority believe it's A as their second choice. A should be that winner. What about the method of elimination? And this method would be where the voters would put in their votes in the same as before, but the candidate with the least amount of votes would be eliminated from the system. So A would be eliminated after the first round for only having 2 votes. But in the first round, when we got to see their second choice, we get to see that the majority would have preferred A. There seems to be no doubt that A's election would be the most generally accepted, and yet, by the above rule, they're excluded immediately, and that ultimately C would get to win as we go round by round. If we were to try to compare candidates 1 to 1 and have more than one candidate, as is often the case in elections. So if we first compared A to B, we can see that A is preferred over B 7 times versus the 6 times that B would win. A is preferred to C 4 out of 9 times. We see that A is preferred to D 6 out of 7 times. So A doesn't win against the other candidates, but does win against B. B, on the other hand, beats C 10 out of 3 times. And we see this all just by lining up on a table and counting the times our letter comes in over the other letters. So B beats C. B beats D 9 out of 4 times. So now this starts getting really confusing. And C beats D 7 out of 6 times. So A is preferred to B, B is preferred to C, C is preferred to D, but we can also find that D gets preferred over A. So we see here that D comes up 3 times over top, 6 times over top, 7 times over top, and that would look to where A comes over top these 4 times, these 6 times. So we wind up with a very cylindrical situation where in order to choose a winner, when we just compare one candidate to another, and then that one to the next, and that one to the next. So to try and compare only in pairs, we wind up with a very cylindrical situation where no one gets to be the win simply because we just go round and round. So even a 1-to-1 comparison doesn't work. it is impossible to have a truly straight across the board fair election without these two situations happening, which any person that does not show up to vote gets considered a vote against both candidates. Don't forget, if you've liked this video or found it helpful, like, subscribe, and share with your friends.